So hello everyone, in this video we are going to see about what is trees. So what I'm doing is I'm making a complete playlist on trees and various problems on trees. So first of all we will start from the basics, that so that if anyone doesn't know about what is trees, he will also get to understand, and uh, and in the subsequent videos we will try to solve some questions on trees as well. So let's start with this video. First of all, let's see what is a tree and some of the terminologies related to trees. First of all, as you can see written over here, a tree is a non-linear data structure, and also it is also called as a hierarchical data structure. So first of all, what is meant by non-linear is, like arrays, the arrays, suppose let's take an example of an array only. So suppose this is an array 10, 20 and 30. Now when the elements of this array are stored in memory, they are going to be stored in contiguous locations. But when we talk about binary tree or tree in general, in that case the elements are not stored in contiguous manner. The elements of or the nodes of tree can be stored in any manner in the memory. And hierarchical, we are calling it as hierarchical because the there are levels, different levels in the tree. Suppose this is one level, this is another level, so these elements are stored in level wise. That is why we are calling it as hierarchical data structure. Okay, so now let's start with the, first of all let's start with the terminologies. So what is a node? So all these, you can see that this numbers which are inside circle are nodes. So 10, 20, 30, 40, 50, 60, all these are nodes of a tree. Okay, so 10 is a node, again 20 is a node, 30 is a node. Similarly, all these are the nodes of a tree. So let's move ahead. So we have covered what is a node. Now let's see what is a root. So root, every tree has only single root. Okay, so in this case the root is 10. The topmost node that is in a given tree is a root node. Okay, so now let's see what is a child node. So the child node, first of all, the child node, the node which is immediate successor of a node, is called the child node. Suppose uh, let's take 10 as the node, and then the immediate successor of 10 is 20 and 30. So 20 and 30 are the child of 10. Similarly, when we will see 30, the child of 30 are 60 and 70, or we can say children of, because there are more than one children, so it is, we can say 60 and 70 are the children of 30. And similarly for any node we can say how many children are there. For suppose 70, the node 70 has 3 children, 5, 6 and 7. And if we see the node 50, it does not have any children. Okay, so let's write one example. Child of 10 is 20 and 30. Okay, so now let's move on to the next node, that is leaf node. So leaf node is also called as external node. So what is a leaf node? The nodes which do not have any child nodes are called as leaf node. Suppose for in this given example we have different nodes like 10, 20, 30. So suppose like 10 is having the children 20 and 30, but 40 doesn't have any children, so 40 can be called as a leaf node. Similarly 50 doesn't have any children, so it is a leaf node. So 40, 50, 60, 5, 6, 7, all these are leaf nodes. So let's write them. 40, 50, 60, 5, 6 and 7, these are the leaf nodes. Now let's see parent node. So for any given node, suppose let's take the node 20. The node which is predecessor of 20 is can be called as its parent node. So for 20 the predecessor is 10, the one which is coming before it, so 10 is the parent of 20. Similarly 30, for 30 the parent is 10. For 70, if we will see, the parent is 30. For 6 the parent is 70. So let's take an example. Parent of let's write for 60. Parent of 60 is what? Parent of 60 is 30. So now we have covered parent. So the next terminology is ancestors. Okay, so there can be more than one ancestors for any given node. So any predecessor node on the path of the root to that node are called as ancestors of that node. For example, for 50, the ancestors can be 20, 10, and similarly if we will see for 5, so 70, 30, 10. So that is all the nodes which are coming on the path towards the root, so they can be called as ancestors. So let's write the ancestors of 40. So ancestors of 40 are 20 and 10. Okay, so similarly we have descendants. Descendants are the opposite of ancestors. Any successor node on the path from the leaf node to that node. Suppose we have a node 30, so all the successor nodes to the 30 till the leaf node are uh, descendants. So for 30 we can say 70 and 6 are the descendants. For 20, 50 is the descendant. Okay, so let's write the descendant of 20, which will be 40 and 50. So now let's see what is a subtree. So for a given tree, subtree can be any node of the tree along with its descendants. Suppose for this given tree, this can be a subtree, 20, 40 and 50. Okay, again this whole can be a subtree. There can be many subtrees possible. Again this one can be a subtree. So similarly all these are the subtrees of a given tree. Okay, now let's see what is the degree. So degree in a tree can be defined as the total count of subtrees attached to that node. For example, for 20, let's see the degree for this subtree. So the degree for this will be 2 because 20 has 2 children. Okay, for similarly if we will see for the complete tree, that is this one, 10, from 10 if you will see, so 10 has 2 children, that is 20 and 30. So again for 10 the degree will be 2. For 70 if you will see, the degree will be 3 because it is having 3 children. These 3 are the children. So let's write the degree of 70. It will be 3 because since it is having 3 children. Okay, so now let's move on to our next terminology. Okay, sorry, so it will be degree of 70 will be 3. And now the last one is internal nodes. So all the nodes which are coming after the root node and which is coming between the root node and the leaf nodes are called as internal nodes. So 10 cannot be called as an internal node because 10 is a leaf node. Also 40 cannot be called as an internal node because 40 is acting as a leaf node. So 20 and 30 can be called as a internal node. Also 70 can be called as an internal node. So the internal nodes can be 20, 30. Also 70 can be called as the root internal node. Other than this, all the other nodes are either the root node or leaf node. So with this, the basic terminology, we have covered the basic terminologies of a tree. Now we will see how can we implement a tree in C++. So before moving towards the implementation of trees, let's now first of all see what are some of the applications of trees. So first of all, trees are used to store hierarchical data like folder structure, organization structure. Suppose we have files and folders in our computers, right? So they are stored in hierarchical order. Similarly, we have HTML tags. HTML tags, you can see that first of all is the title, right? And then other, suppose if we have a body tag, then in body tag, inside body tag we can use other tags also. So this is what a hierarchical manner in which we can store the data. So that is so this is one of the applications of trees. Looking forward to the other applications. So the other application is BST or binary search tree. Also a binary tree can also be a application of tree. So what is a binary search tree? We will see in the upcoming videos. For now, let's understand what is a binary tree. Suppose for example, this is 10 and it is having two children, 20 and 30. So this can be called as a binary tree. Since it is having two children, that is binary. So that is why we are calling it as binary tree. Suppose if it is having one more children, that is 40. So now it cannot be called as a binary tree because now it is having three children. So this is another application of tree. Moving forward, a heap in heap data structure that we have is also implemented using tree. B tree and B plus tree in database, they are used to implement indexing in databases. So they are also implemented using tree only. Try is another data structure which is used to implement dictionaries with prefix lookup. So this can also be implemented using tree. Again, in computer networks, we have shortest path trees, that is to find the minimum distance. In that case also we can make use of trees. So these are some of the applications of trees. Now let's move forward and see the implementation of trees. How can we implement trees? So first of all, what is a binary tree? So as I told you, any tree having two children can be called as binary tree. So not only we cannot say this, the official definition can be like this: any tree having at most two trees. So this makes a very much at most two children, sorry. So this makes a very much big difference. That is, suppose if this is a tree, it can also be called as binary tree. Again, if we have this tree, this is also a binary tree. Again, this tree, this is also a binary tree, because we have said at most two children. So it can be any children. That is, if a tree has 0 children, then also it can be called as a binary tree. If it has only one children, then also it can be called as a binary tree. Also, if it has two children, it can be called as a binary tree. If it has more than two children, it cannot be called as a binary tree. Okay, so let's now see how a binary tree is how it is stored in the memory. Suppose if we have a node 10, then we can also represent it using like this. So what are these? These are the left node, that is the pointer to the left node, and the pointer to the right node. So for 20, if we will make it, so the node will be stored in between, and for 20 the left node is 40, so the pointer will points towards the 40, and for 40 there is no nodes, so it will be null over here. For 20 there is no right node, so it can be marked as null. Again, for 10, if you will see, the right node is 30. Now for 30, the left node is 50, so we can represent it like this. So this type of representation gives a much more logical view of a tree. So again, 50 does not have any left and right children or nodes. For 30, the right node is 60, and 60 doesn't have any nodes. So here this clause represents null. So this is a much more logical view of a tree. Now let's see how can we code this in C++. So first of all, for making a node, we have to create a structure, and then we will define the left and right nodes of the root node. So first of all, let's see the struct node. We will create a structure and name it as node, and first what it will have is, it will have one key, it will have a left pointer and a right pointer. So if this is, I have created a node and a left pointer and a right pointer. Okay, so also when we have seen the logical view, we have seen it like this. So this is also means the same only. So suppose in the key we will write 10, so this will act as the key, and in the left and right these are basically the pointers to the other nodes. Okay, so what we have done over here in this line, that is node int of k, this is a constructor that we have called. So every time we call a node, a constructor will automatically be called and it will assign the values to the key and left and right pointers. Okay, so let's now come to the main function. So what is happening over here is we are creating a root node and we are allocating the memory dynamically, that is with the new keyword we can use in C++. So suppose when we run this first statement, what happens is memory will be allocated to the node. So what we have done over here is we have called the node. So when we call the node, this constructor is called and the key is assigned the value, this whatever we have passed over here, that is 10. Okay, so our key is 10 over here in this case, and the left and right pointers are initially we have marked as null. Okay, you can see in the constructor left and right are marked as null. Now when the second statement is called, some changes will happen, that is the root of left, that is for this node that we have 10, the root is 10, and the left node that is marked currently, which is marked as null, we are assigning the left node, the left pointer as 20. So now the left pointer will points to 20. Again, this is happening in a recursive fashion. So the left and right pointers of this 20, the node 20 will be null. And after once this line is implemented, our tree will be looking like this. And when we implement this line, our tree will look like this, because what we are doing is we are marking root of right, that is the root is 10 and the right pointer will be pointing towards the node 30. So with this statement what we have done is, that is new node 30, we have created this node basically. Okay, and when we assign this node to root of right, what does this mean is this will create a pointer towards in between both of them, that is 10 and 30. So this pointer will be created after the implementation of this third line, and these two pointers will be marked as null. So this is the basic implementation of a binary tree in C++. We can create different, basically while coding, binary tree is only much more used. We will also look at binary search tree in the upcoming videos. For now, that's all for this video. In the next video, we will see the traversals on tree, that is pre-order, post-order, and in order. So thank you. If you like the video, consider subscribing to the channel, and to see more such videos, you can access the playlist section of my channel. Thank you.